Hello everyone, Assalamualaikum and a very good morning. To our dear guests, viewers and participants, good morning and welcome to the first episode of NanoTech Talk 2022 webinar series. We appreciate if you can be with us throughout the sessions. Today's episode will start shortly. To all viewers, listeners and participants, you can leave your questions in the comment section below. Our speaker will try to answer the questions at the end of the session. Thank you. Ladies and gentlemen, welcome to the NanoTech Talk 2022 webinar series. My name is Amirul and I'll be your host for today. Before we start our session today, I would like to invite all of you to the NanoMalaysia virtual exhibition booth at Minggu Sains Negara, Keluarga Malaysia MSN 2022. MSN 2022 is a virtual event open to the public from April until October this year. There are more than 110 virtual programs, activities that can be participated, such as exhibitions, workshops, forums, seminars, learning and quizzes, and flagship programs. All these you can participate at www.minggusainsnegara.com. To begin our webinar this morning, I would like to share a bit of information about our webinar. NanoTech Talk is a yearly event by NanoMalaysia Berhad that focuses on 4 key strategic sectors: electronic devices and systems, food and agriculture, energy and environment, wellness, medical and healthcare. Our theme for today is Malaysia and its technological innovation for food security. It is a 45-minute sessions by NanoMalaysia and our partners, and we will be sharing about opportunities for industries and SMEs in nanotechnology market, focusing on the food security sectors. This webinar consists of 4 sessions, starting on 4th April 2022 until 6th April 2022. This webinar aims to showcase valuable insights by featuring the market trends and issues mainly for industry, companies, startups who would like to venture into nanotechnology and understand what NanoMalaysia offers. Distinguished guests, ladies and gentlemen, viewers, listeners, and participants, before we start the session, allow me to give a brief introduction about our session today. Our invited speaker for today will be technologist Dr. Mahalakshmi Arujanan. Technologist Dr. Mahalakshmi Arujanan is the Global Coordinator of the Biotrust Consortium ISAAA Biotrust and the Executive Director of the Malaysian Biotechnology Information Centre MABIC. Dr. Maha is also a professional technologist recognized by the Malaysian Board of Technologies MBOT and the founder and editor-in-chief of the Petri Dish, the first science newspaper in Malaysia and the Asian short course on agri-biotechnology, biosafety regulations and communications, ASCA. Dr. Maha is listed as the world 100 most influential people in biotechnology by Scientific American Worldview 2015. She is also listed in the honorific list of women in biotechnology law and regulation as part of Biotechnology Law Report 2015, published by Mary Ann Liebert Incorporated, among 20 others women, scientists and lawyers. Dr. Maha won the 2010 Third World Academy of Science Regional Prize for Public Understanding of Science for East, Southeast Asia and Pacific region. The topic for today will be genetic technologies for food security. Without further ado, I will give the floor to our speaker today. Dipersilakan Dr. Maha.
Terima kasih Amirul, and good morning everyone. Salam Ramadan to everyone. Hoping that everyone is having a blessed Ramadan month. So let me start with this topic. I think NanoMalaysia has chosen a very timely and very important sector or field that really require a lot of attention. In fact, I would say serious, urgent attention, because our food bill is very high and we really need to look at how we can work on sustainable food security. Now, if you notice here, I'm not just saying food security, I have included sustainable food security, because it's not just about having enough food, but then neglecting our environment. So when we increase our food production, we must also make sure that it does not create so much of negative impact to the environment. So that I'm going to talk about basically biotechnology, because there's no one solution to achieve sustainable food production. Mechanization and talent development, policies, so many things must be in place. I'm going to focus on what biotechnology can offer to achieve sustainable food production. Now, I like to always demystify what agriculture is. For a lot of us, agriculture means it's very pristine, very beautiful. It is like a village, countryside, fresh food, fresh air, but that is not really what we will see in real agriculture field or farms. There's so much of biomass. For example, in Malaysia, we have a lot of biomass from the oil palm industry. Then we have got all the straw from the rice field. Agriculture also produces a lot of greenhouse gases. In fact, agriculture is the second largest industry that produces greenhouse gases. So this include carbon dioxide, methane, and nitrogen dioxide. So, and the methane comes from cattle belching. That means the cattle's, when they belch, a lot of methane is released, and also from natural synthetic fertilizers and manure management. The fertilizers, rice cultivation, rice field actually releases a lot of methane, and field burning of crop residues and fuel used in farms also produces carbon dioxide. There's a lot of soil erosion, water. It takes off the topsoil, which is actually what contains a lot of organic material, and that is bad. And now we also have so many crises, global crises. The pandemic resulted in a lot of disruption in agriculture. Food could not be sent to other places. And of course, now we have got the war as well, Ukraine and Russia. And we know Ukraine is a top producer of wheat. So if Ukraine cannot export their wheat, then the wheat price is going to increase. So that's going to be a shortage of food as well. Now, in spite of all these challenges, the reality is we need to produce 70% more food, more than what we are currently producing. That is estimated by FAO, UN Food and Agriculture Organization. Now, how do we do it in spite, with all these challenges we are facing, global challenges, lack of natural resources, environmental impact, and then man-made conflicts like war and the pandemic. So this is really going to be a challenge, and this is where we need technology. So food security itself, I think we need to understand what food security is. For a lot of people, food security is just, is there enough food? Now that alone is not food security. Availability is only one component of food security. There can be a lot of enough food, but then I cannot have access to food because it doesn't reach my kampung, it doesn't reach my my town, or it reaches my town, but then I cannot afford to have this food. So affordability and accessibility is also very important. Now, utilization, how is food utilized? We can have a lot of food, but are we just eating just starch and carbohydrate, devoid of vitamins and minerals? So this is also another issue, malnutrition. Do we eat balanced food? So that's another thing. And then stability, food can be produced, but do we have year-round food? So there must be stability in price as well as stability in the availability. So these are the components of food security. So what are the impact of biotechnology in sustainable food security? What can we achieve by employing biotechnology in agriculture? Now here, the one in brown is increased yield. If you look at all the brown, the benefits in the brown box, you will see these benefits are mainly directly related to the farmers. So increase in yield. So farmers have better yield because we've got better variety of seeds. And farmers also have better agronomic traits, like the crops are now tolerant to abiotic and biotic stresses like pests, diseases, weed management. They can do well in spite of extreme weather, maybe frost or low temperature, lack of sunlight, or drought, and also lack of fertilizers. So fertilizers, I've mentioned, fertilizer causes a lot of environmental impact. So can we start growing crops with reduced fertilizer by increasing the bioavailability of the crop? So as I said, the brown box is mainly the benefits related to farmers. Now, biotechnology also offers advantages to consumers like us, fortified food crops. So we can have food crops that are now fortified with higher levels of vitamins or minerals or even antioxidants, for example. We'll see some of the examples. That's what we call that the functional foods. Can we eliminate allergens? A lot of people are allergic to gluten. A lot of people are allergic to peanuts. So can we eliminate the allergens? So now this food can be available to everyone. Non-browning, we will also look at this example later. We know apples, when we cut, it becomes brown. That causes food wastage, a lot of food wastage. So can we make non-browning apple, non-browning mushroom, non-browning potato, or even brinjal becomes brown, banana becomes brown. So these are the things that biotechnology offers. Less natural toxin or carcinogen. There are actually phytotoxins, natural toxins, plant toxins in many plants. So can we reduce that? So there will be food that will be available for everyone. So if you look at the green box, these are the advantages to the consumers. Because initially people, the activists who are against biotechnology claimed that biotechnology only brings benefits to the industry and farmers. That's not true. It brings benefits to farmers, consumers, and also the environment. So the green box is the advantages to the environment. So now there will be less greenhouse gas emission because we can reduce use of fertilizers, we can reduce use of pesticide, we can have kettles that do not belch so much, they do not produce methane, transgenic cattle. We can also have reduce the use of toxic herbicides. So I will also come to some of the examples later. So this is what biotechnology can offer towards sustainable food security. So before we go to biotechnology, we often think that the public think that only because of biotechnology, our crops are modified. This is not true. Our crops have been modified since men started learning how to select the best seeds and make them, cross them. So at that time itself, when cultivation happened, the genetics of the wild varieties were altered. So we had traditional breeding, for example, crossing of selected offspring, and then they cross the best offspring, and then the genes are modified. Although these genes are reshuffled within the same varieties, not from rice to bacteria or rice from corn. These are the same varieties, reshuffling happening through the same varieties. So number of genes are reshuffled, but traditional breeding does not require any regulation. So these can go into the farms immediately. The other traditional breeding is mutagenesis. Mutation happens when crops, or even us, our cells are exposed to chemicals or irradiation. So what scientists do is they expose seeds, plants to chemicals and radiation, and then some reshuffling again happens there. And when desired traits are seen, these traits are then used for commercially and is released to the market. Again, this does not require any regulations. So the next three are considered genetically modified, and they are molecular biology, where RNA interference. So this is an example. For example, the rainbow papaya is RNA interference. So the RNA produces the protein. Now, if we play around with RNA, interfere with RNA, and maybe stop it from producing certain protein, then we can eliminate what we don't want. So only a few genes are changed here, unlike mutagenesis and traditional breeding. So this is how RNA interference work, but this is highly regulated because it's considered genetically modified. Now, the other one is transgenic or GMO, genetically modified organisms, where genes that have a beneficial trait, for example, the bacteria, a soil bacteria, Bacillus thuringiensis, it has got a gene that produces a protein that is toxic to lepidopterans. These are the borers. If you see brinjal, there'll be a very small hole on the brinjal, but when we cut, there'll be a huge maggot inside. So these are the borers. So these borers will go into the, even before the fruiting, it goes into the shoot, and then it starts when it starts in the flower itself, and the fruit then has these borers. It is very difficult to get rid of these borers by just spraying pesticide, because they are very safe inside the brinjal or corn or cotton. They're very safe inside. So farmers can be spraying so much of chemicals, but they do not die. So where does the chemical go? To the environment, to consumers like us. So what scientists have done is they have spliced that gene from the bacteria, put it into a bacterial gene, and then transferred that gene into corn, cotton, and canola, brinjal. So now these crops confers the resistance to the pest. So when the pests come and eat the crops, the pests die. So this, what the changes happen is only about 1 to 8 genes. So it's not a random change. Scientists know what changes are being done. Anyway, these are highly regulated. Now, the latest one is gene editing, where genes are edited. That means it's like we just change very small number of changes. I'll also talk about this later, and only 1 or 2 genes here. And again, these are regulated, but again, these have got mixed regulations. Some countries are exempting certain type of gene editing. Some countries are considering all gene editing as GMO. So we will also go into that in a bit. So what are these crops that are genetically modified? There are about 13 crops in the world, in the market, commercially available, which means they've gone through all the safety processes, regulations, approved, field trials, everything. So these are corn, soybean, cotton, canola, papaya, squash, this is alfalfa, brinjal, sugarcane, potato, apple, and this is sugar beet and pineapple, and there's also mushroom, but that is not GMO. It's genetic. It's gene editing. So these are the crops which are available in the world in many countries. We, Malaysia, we do not grow anything, but then we import the corn and soybean and cotton. Probably what we import cotton, they are also genetically modified. If you see canola oil, they could be genetically modified. So mainly the top, the 4 in Malaysia are most likely genetically modified, but then we don't have to worry, because our Ministry of Environment and Department of Biosafety, they go through all the safety aspects, and then it is approved by the experts in Malaysia. So the first generation of GM crops, or genetically modified crops, are mainly the traits that benefits the farmers, like what I said earlier. So it's herbicide tolerant crop, meaning if farmers can spray herbicide to the farm, only the weeds will die, the crops will not die. Now the question is, oh, then you can spray so much. Well, farmers would not spray so much because they don't want to waste chemicals. It's money. Yeah, and the advantage of herbicide tolerant crop is now farmers only use that certain type of herbicide, because previously they were using all kind of herbicides which can be even more toxic. So now farmers have reduced the more toxic herbicide and use only the one which gives the tolerance to the crops. Now then there's insect resistant crop. I've already mentioned this, how the Bacillus thuringiensis gene confers the insect resistant to the crops. So the crops now produces the same protein, and the pest will die if they eat these crops. And then again, the question is, how about us? We will be eating the crop. Now this protein is only specifically active on the corn borers and those type of pests, not to us, because it cannot act in a gut system which is acidic, and we all know our gut, our stomach is very acidic, so it will get digested, so nothing will happen. So there are crops that can have higher yield, virus resistant crops like papaya, squash, drought tolerant crops like sugarcane, wheat, crops that can grow in arid area. These are the drought tolerant crops that can grow in saline areas being developed. So, I've already mentioned the crops that are available. So which are the countries that are growing this crop? There are 29 countries in the world, and half of them, or even more than half of them, are actually developing countries, not the developed ones, developing countries. Of course, the big countries, US, Canada, and then Latin America, Australia, India is growing. So if you go to ISA, you look at, see here, ISAAA.org, you will have this slide there. This particular thing, and you will see what are they growing, how much are they growing. So 29 countries, 17 million farmers are growing biotech crops or GM crops, and you see many countries in Africa is coming up. Africa is coming up very strong because they realize that this is really important for them. Latin America has been there for a long time, so things are also changing with gene editing. So as I said, it started with developed nations, of course, US, and as it was being adopted, 2010 saw for the first time developing nation adopting more biotech crops than the developed nations, because there's already saturation in developed nations. That new countries like Europe is not coming in for political reasons because they don't need. So, but developed nations find there's really a need to increase food security and also sustainability. So we see the developing countries are going up. So the total is 190 million hectares. So what are, again, the how it can support sustainable food production? And these are documented with the data. It increases food productivity. So as it was first introduced in 1996, and until 2018, it has increased food productivity 225 billion. What does that mean? If we can increase food productivity, we don't have to open new areas of forest. So it's sustainability, right? We can maintain our forest and other areas. Conserves biodiversity because, as I said, the forest can just now remain. So the biodiversity is conserved. Provide better environment. It reduces pesticide. Only certain herbicides are being used. It reduces carbon dioxide from being released from the soil, because farmers, when they use herbicide tolerant crops, they don't have to plow the land, because plowing the land, when you turn the soil upside down, a lot of carbon dioxide is released. They do that because they want to make sure that all the seeds of the weed are killed. So now they don't have to do that. So all this combined, it saves 776 million kilograms of carbon dioxide from being released to the air. It's really a big number. Reduced carbon dioxide emission, and helps, of course, helps poverty, because we know the farmers are the poorest of all. So it helps farmers to elevate poverty. And also the farmer's family. I personally have seen how farmers are so happy in many countries, Philippines, India, where they say they are now able to send their children to college. They're able to buy a motorbike. They're able to buy tractors. They are able to rebuild their house. So it's really, it's something that really makes us who support this technology happy. And we know food wastage is a real huge problem in the food supply chain. This happens pre-harvest, meaning before harvest, meaning it is in the farm where it is lost due to pests and insects and diseases. A lot happens here, and this mainly happens in developing countries because developed nations have got their measures. Post-harvest, after harvesting, it is lost in the storage, during food preparation, during storage, because again, it could be fungus in the storage, or it could be browning, and during packaging, and it's highly perishable. So food wastage is another thing, and this again, biotechnology can help in these areas. So it is good to have biotechnology, but in agriculture, but then the process is also very long. It takes about 10 to 15 years from the proof of concept to product development, and then the event is approved. Then it goes for performance trials, safety trials, to make sure that it's stable. So all this takes about 10 to 15 years. To ensure that it's really safe, the food safety, environmental safety is all determined. Toxicity study, compositional studies, analysis, protein analysis, DNA analysis, field trials are all done. And it goes into many government agencies until it reaches the commercial release. So how much does it cost? It costs about 136 $1 million US dollars. So it's a huge amount. And that is why we see many international companies are there, not public sector. So we need to support public sector so they are also able to produce GM crops. So where does this money go? The discovery, that means the protein itself, the process, R&D process takes about 23% of this amount. But regulatory takes more than that. Regulatory takes 26%. So if we can be more pragmatic about the regulations, we are not so, of course, safety has to be taken into account. It cannot be compromised. But a lot of time, what happens is the regulatory bodies or the public and the environmentalists, they want so much things that's really not necessary to ascertain its safety. So we always say it is not the information that we want to know, it's the information that we need to know. It's nice to say, okay, 100 years from now, what will happen? But it's something that, we already know 30 years, GM crops have not produced any harmful, disastrous results. So it's time to relax a lot of these regulations so that this 136 million US dollars can be reduced so that our public sector can get into this field. So we don't depend on the private sectors and then it becomes like food monopoly. So this is what happens, discovery of a trait. Where can I get this gene that I want? So that takes about 54 months, and then proof of concept 27 months, early development, putting the gene inside, making sure that it really works and there's stability at 30 months, and then advanced development, and finally pre-launching. All those safety tests is about 2 years, or sometimes it can even be longer. So you see, it's a long process. And this is where I feel countries like Malaysia, we really need to have the stamina. We cannot say, I'm going to invest today, and then immediately 6 months down the road, you want a seed. It doesn't happen. We need to have stamina. We can fail in between, but our politicians, policymakers, and government officials must provide the timing and the funding to our scientists. If not, it will always be at the discovery proof of concept, and then it's dropped, and then we move on to another project, and then plow money back, and then we dropped, move on to another project. I think this is what is happening. So we really must understand how this works, so we can have the investment time and the support so that we really come to the end until it can be commercialized. So it gives us the return of investment for what we have invested. So crop that support food safety and nutrition, this is potato. It doesn't brown, and it also reduced acrylamide. Now, when we eat fries, French fries, for example, it is very high in starch, and when it is cooked or fried under very high temperature, acrylamide is formed. Acrylamide is like a plastic type of chemical, and it is a known carcinogen. So what scientists or this innate company has done is, Simplot has done is, they've reduced the level of acrylamide. A non-browning apple, a lot of apple is wasted in the industry because it browns, so it is thrown away. Now, can you imagine if we throw away our food, how much of resources has gone in, how much of time has gone in, how much of impact it has created to the environment? After all these things, we throw away the food. So it's really a waste. Costa Rica now is planting pink pineapple. It is an antioxidant, and it is known to reduce the risk of cancer. Golden rice has been there for so long, but was not in the market because so much of propaganda by anti-biotech people. Now it is going to be, it's approved in the Philippines. I think soon it will be approved in Bangladesh as well. So high oleic soy canola and also high oleic soy as well. So what happens is with high oleic soy, it reduces the cardiovascular risk of consuming fatty acids. Now, can we do this for palm oil? Definitely we can do this. So make our palm oil healthier. So this purple tomato, also again something like the pink pineapple, very high in antioxidant, very good to prevent cancer. Browning, non-browning mushroom, this is a gene edited technology. So you see a lot of benefits to the farmers, to the consumers. So now we move on to gene editing. Gene editing is simply like a Word document. You just find and replace the one word that you have accidentally put in. For example, if you made an essay or talking about custard, and instead of custard, you typed mustard throughout the essay. Now you don't have to delete your file. We can, what we do, we just search for mustard, we replace it with custard. The same with gene editing. I'm just putting it in a simple version. So deletion can take place with gene editing, where you see this C, cytosine is replaced with adenosine. Thymine, no, the cytosine is just deleted here. So replacement can also take place where GT is replaced with AA. So these are how gene editing takes place. And gene editing is also something that occurs naturally. It takes place in bacteria. It's a natural bacterial defense mechanism, which scientists see an opportunity for agriculture as well as medical opportunities. So gene editing enable beneficial traits, like it can help to produce drought tolerance to in crops, deactivating or eliminating unfavorable characteristics, like we don't want certain disease, we want the plant to be disease resistant, and it also can be in between both. We can also have both unfavorable beneficial and also elimination of unfavorable characteristics. There are crops already in the market for gene editing, genome edited canola, rapeseed. This is herbicide tolerance. These are already there. And it is not in all the market, but some countries have approved this. Genome edited tilapia, this is not approved yet, but it's already ready for market. Small deletion, and it is to improve fillet yield. Genome edited bacteria, again for biological fertilization, and the trait is increased nitrogen availability. So now you see, with increased nitrogen availability, we don't have to put so much of our NPK, the nitrogen fertilizer. So impact of sustainable food security. Now, smarter use. If we can employ these technologies, we'll have smarter use of pesticides and other agricultural inputs, meaning the cost is going to be reduced, the impact, the negative impact to the environment is going to be reduced. Enhanced nutrition, we have all saw that. Food safety, food can be safer because, say, less acrylamide and no allergens, no toxins. Quality of food increased, farmer income, and better use of land. We don't have to open up all our land for agriculture. Impact of innovators. Now you see, when GM crops was approved, we saw mostly the crops, the new traits were coming from multinational companies. That is why the environmentalists were saying, oh, these are all going to be monopolized by multinational companies, and all the crops only favors them. That is one reason why we don't have GM crop here, because we can't grow cotton, we can't grow soybean, and corn we can grow, but we need facilities to grow corn. So why? Because they were developing the crops that they can market, has got huge market. So we saw here during the times of GM crops, more multinational, very small number of SMEs and national research institutes. But now with gene editing, what's happening? The multinational has become so small. This is what the environmentalists want, right? So they should be supporting gene editing. The foreign SMEs are becoming so big, and the national SMEs and research institutes, public sector is coming in. So I think this is a real good opportunity for Malaysia to move into this area. So if we look at Argentina as an example, Argentina is so progressive. Approved GMO, mainly cereals, corn and right, oil seeds, canola and soybean, fiber crop, and small number of vegetables. But if we look at precision breeding products, which is actually gene edited, we are able to transform more products of agriculture, like microorganisms, like what we saw earlier, that can improve fertilizer availability, cereals, oilseed, fruits, vegetable, ornamental, livestock, fish. Now, this is where Malaysian scientists now can use gene editing to really work on the crops, on the animals, on the microbes that is of interest to us, not just globally, but what is of our interest, what will serve our purpose. So homegrown technology regulations in Asia and Africa, in fact, around the world, it is really becoming big. Our neighbor, Indonesia, they developed their own drought-tolerant sugarcane, completely from scratch, public sector and private sector collaboration. See, it's their own, not Monsanto, not Bayer, it's their own. India has got dozens of GM crops ready for commercialization, but again, the political will, their activists are so not friendly. Bangladesh is the first country to commercialize BT brinjal. It was developed in India, in the Philippines, but Bangladesh, the political will was so strong that they saw the need. Next, they are going to approve golden rice, blight-resistant potato as well. Nigeria, another underdeveloped or developing country, again, their homegrown technology, cowpea, they have developed that and now it is being grown. So just like that, Kenya, Eswatini and Sudan are all coming up with their own field trials, testing the products and coming up with their own cassava and many other crops that is of interest to them. So this is why we need our scientists to work on it, not depend on multinationals to deliver what we want. So I think these are really big lessons for us to move forward. So where's Malaysia? Our food bill is 55.4 billion ringgit in 2020. Very, very huge. And it's growing every year. Primary forest loss in Malaysia in 2019 was 120,000 hectares, and 50,000 of this is in Peninsular Malaysia. This is by Global Forest Watch. And we still don't have regulations and guidelines for gene editing yet. Although many countries are already either exempting certain type of gene editing, or they are having special regulations for gene edited. We are still, we are not there yet. R&D on GM is lagging, and this is another huge problem. As I said, a lot of scientists were working on it and then they dropped it because they didn't have the stamina, no investment, and it was very stringent for them to work. So that's another huge problem. Way forward. So enabling science-based regulations is very important, and enabling implementation of regulations. We need regulations that are enabling, not stifling. We need investment. We need to move forward with gene editing. Homegrown technologies don't depend on others. Our scientists, our breeders have to work on it. And we need to work very hard on awareness, acceptance, and political will. And this is where communication is very important. So if we look at gene editing, you see Canada not regulating, and Colombia, Brazil, Argentina, they're going by case. Certain things are not GMOs for gene editing. Paraguay, case by case. Nigeria, Kenya, case by case. United States, most gene edited are not considered transgenic. United Kingdom, after post-Brexit, they are becoming friendlier to biotech. So EU and EU, of course, they are still very negative about GM and gene editing. India is here. It is yellow, but India is the latest to say they are not going to edit SDN1 and SDN2. Australia not regulating. So Philippines discussion going on. So Malaysia, there was one meeting, but then again it was still not going in, zooming into gene editing. They're still talking about GM. So which means even our stakeholders still don't understand GM. So how are we going to move into gene editing? So I think something really have to be done. So with that, that's the end of my talk, and I communicate science actively on all my social media. So yeah, I'm just going to pass it over to Amirul, and I'm going to take my power, because my power, I'm running low in battery. I'll be in a minute while Amirul takes over for a bit. Thank you so much.
So thank you, Dr. Maha, for your presentation. What a solid presentation, full of in-depth information about the importance of food security, which shows some differences in the market locally and globally. For all viewers out there, if you like to understand more about Dr. Maha's slide presentation, be informed that this session will be stored on the MSM platform and Nano Malaysia's Facebook page. You can always watch it again at your own free time. Okay, before we end our session, there are a few questions from the viewers and participants, mostly from Nano Malaysia Facebook page. On the first question from Mr. Devandran Krishnan. Hi, Dr. Maha. Good point on affordability as part of the food security value chain. Any suggestion on how this can be achieved apart from increasing consumers' buying power?
Okay, so of course those in science, we can only talk about science, right? We are not going to talk about consumers buying power or whatever. So you see, what was the recent headline? The recent headline was corn price is high and our chicken price is going high. Can you imagine what is going to happen during Ramadan, during Hari Raya, or normal days when chicken price is high? Chicken is the cheapest protein. And we can't expect everyone to buy fish. Fish is actually very expensive. So what we can do is, how can we increase our corn production? Or how can we find alternative to corn? So these are the things that science, agriculture, biotechnology can offer. So the thing is about having enough food so the price can go down. So that is one thing. But of course, today I spoke a lot about biotechnology. There are many other areas that we need to have, not just one solution. The others is urban farming. And I'm not an idealistic where we say everyone farm. I mean, not everyone can farm. Do you have the time? Do you have the land? Do you have the expertise? So not like I come back home from work and then I start farming, in my backyard. It's not feasible. So we need more feasible things, like, can we have within the city, maybe some urban farming, those, young people who want to go into this, how can we support them? So I think these are some of the things that we can do so that the transport cost is reduced. Right? Because we don't have to wait until it comes from Cameron Highlands. We can have it just near somewhere within the city. So these are just some of the things that we can do. There are already indoor aquaculture. Can we do that? And I think by doing that, it not only increases the buying power, but it also offers job for our younger people. A lot of young people, they want to be entrepreneur. They don't know what to do. They don't know how to do. So probably these are the things that we could do. Just, there are a lot of other answers, but very shortly, I can think about this. Thank you. Thank you for the question.
Thank you, Dr. Maha. Just to add on top of Dr. Maha's answers, for your information out there, Nano Malaysia, we ourselves, we have few projects that are related to smart urban farming and aquaponics. So if you'd like to know more about our projects, maybe you can listen and watch our NanoTech talk on the next episode, maybe tomorrow and Wednesday. So on the second question from Sharizal Sharani, Dr. Maha, can you share why is there so much distaste for GMO food in the market?
So much of what, Amirul?
Distaste.
Distaste. Okay.
Yes.
Now, because food is something that is very, very close to our heart. It is, I would say people romanticize food. Like it's something that we put into our body. So we really want to know what we are putting. And genetic modification is like, the term genetic modification is like, first of all, the public don't understand, hey, my food got gene. That means I'm eating gene. So there are a lot of misconception. Science literacy is low. And then, oh, my food is modified. Who are you to modify my food? So all these things, people get very sensitive. That's why I say romanticization of food. And increasingly, I see the change of public behavior towards food. A lot of people who are affluent, more affluent, who are able to choose what they want to eat and where they want to eat, where they want to buy, they want a story behind their food. So they say they like, oh, this is produced by this mache from this kampong, so, oh, there's a mache in this kampong, or this is produced by this auntie, this. So grandmother's recipe, grandfather's seed. So they want that type of food with stories. They don't want the large scale cultivation, intensive cultivation. So that is one thing. And the other thing is because a lot of propaganda has been done by an environmentalists about the safety. Oh, it's Franken food, it can cause cancer, and all those very negative completely unscientific information has gone out to the public. A lot of people are discussing this in social media. So this has created the distaste and distrust as well. But I can tell you there are thousands of independent studies. Government agencies have done tests on all this food that is out in the market, and they are safe. So I think scientists, communicators, policymakers now should go out and really engage the public so that this can be put in the right perspective so we can adopt these technologies. And another reason, there's so many reasons. Another reason is, oh, EU does not approve. That means something must be bad. Why do you think EU is smarter than us? Why do you think EU, our experts are not good enough to approve something? If our experts have approved something, I mean, we have to have trust in our approval system, in our agencies, in our ministries. So it's not just because EU has not approved. Many people in Australia are rejecting vaccine. Are they smarter than us just because they are developed countries? So it's time that we have trust in our scientists, in our agencies, and also look for credible information.
Okay, Dr. Maha, we got two more questions, but this question, they are quite similar to the recent questions. What then is the case for MSG commercially as it is available naturally in tomatoes? For instance, is it safe? How much is it safe? And the second question is, how broiler poultry or layer hens compromised by antibiotic residual issues?
Okay, I'm not an expert in these areas, but MSG and tomato, I really don't understand the question. Are you talking about monosodium glutamate? It has got nothing to do with tomato. It's not produced from tomato. It is produced from starch. I think it's from tapioca starch. After fermentation, they get that. Now, there are mixed information about MSG. I'm not an expert, so I'm not going to talk about it. Yeah, then I might be giving wrong information. Now, the poultry and broiler and ayam kampung or free-range chicken, there's not really so much of science that support that the nutrition in ayam kampung is higher. It is tastier because they eat a lot of other things. You know, they are free ranging, so they eat a lot of other things. Now, when I was a small girl, my grandmother used to have ayam kampung, and I've seen it eating cockroach, and I never ate ayam kampung. But again, now after so long, I'm eating ayam kampung again. The antibiotic, a lot of farms are not using antibiotic for reason it is expensive, and it also it takes a lot of time. Can you imagine thousands of chicks have to be injected one by one? So antibiotic, it's also another propaganda that's created. Now on my Facebook, long time ago, you can go and search it. I have spoken about antibiotic, ayam kampung, the broiler chicken, poultry chicken. So you can have a look at it, but then I can, very short, I can tell you that it's not true that the broiler, the poultry chicken is not safe. It's really not true. It's still protein. Both gives us protein. Now, the question you may ask, then how come ayam kampung is so small and that chicken is like so big? Because they are breeds. They are special breed that all of them are standardized, and at I think 40 days or what, they all become the same weight. That is why you go to any grocer, Tesco, Giant, Village Grocer, you don't have to choose which ayam you want. You take any plastic, it's all the same size because they are special breed. So this special breed are also resistant to diseases. That is why you see everything is standardized. So it's nothing to do with, because they pump in all kind of hormones. It's not true. They are the breeds that makes it resistant. And one more thing which many people don't know. What is the nutrition studies that the nutrition that is most understood in the world is poultry nutrition. Scientists, breeders, farmers, they exactly know how much carbohydrate to give, how much micronutrients to give, how much protein to give. And even we ourselves, we don't know what to eat. How much can I eat? And what I eat is different from what you eat because my genetic is different. But then for chicken, it's that breed, you give the same thing, they all will grow the same way. So the nutrition, this completely understood. That is why they all are it's the same, not even similar, they're probably the same. Unlike ayam kampung, which is led to, eat on their own, and one day you give corn, another day you give rice, another day you give something else. So these are some of the reasons. Thank you.
Thank you, Dr. Maha. I think that's all the questions that we have for today. To Dr. Maha, do you have anything else that you'd like to add, or any piece of advice to our fellow viewers out there?
Okay, to the scientists, I just want to tell you that genetic technologies are so important. I don't have to tell you, you know that. Please don't give up. And I think scientists must really be engaged in policy making. So when there are consultation by ministries, by agencies, your voice will add a lot of weight to how, the way that we want to take in regulating our agricultural biotechnology. And to policymakers, please look at all the other countries. We don't have to reinvent the wheel. We don't have to do everything again to ascertain the safety. And please be transparent. Consultation. I mean, I am invited to all this consultation as well. So I know, you're already transparent, but please listen to everyone, and to the public who are not from science. Please do not look at just social media, internet, and just get your information there. Look for credible information. There are a lot of information. There are a lot of credible information. So please look at credible information out there, so that you can you can distinguish between pseudoscience, fake news, and also the real science. And industry, it is time for industry who can afford it. Please invest in local research so that it supports our research institutes, it supports our universities, our scientists to do work. So I think I've given messages to all the stakeholders.
Thank you very much, Dr. Maha. We have come to an end of our webinar. Therefore, we would like to thank you, especially to Dr. Maha, for your generous time today. But before that, I would like to remind you that we will have other sessions of NanoTech Talk on 5th April 2022, which is tomorrow, by Mr. Hazmi Iman Abbas, Manager and Market Analyst at Nano Verify Sdn Berhad, that will deliver his speech and presentation about the position of nanotech in the global and local food industry. And on 6th April, Wednesday, by Mr. Devendran Krishnan from the NanoTech Program Delivery Office from NanoMalaysia Berhad, that will deliver his presentation about food security, a superset of Malaysian well-being. And on the same day, on Wednesday at 2 p.m. by Mr. Navin Sinatambi, the head of Agritech, Sectorial Pilots and Drone Tech Ecosystem Development Division from Malaysia Digital Economy Corporation Sdn Berhad, MDEC, with his topic of empowering the agriculture sector with digital agri-tech adoption. Thank you once again to our partners, speakers, and participants for joining us today. Thank you very much to Dr. Maha. Don't forget to like and follow our social media to get the latest information and updates. Thank you very much. Terima kasih and stay safe. Bye-bye.
Thank you. Bye-bye.